Welcome to class. How are you doing today? I hope you are doing okay. All right. Today's class we're going to be wonderful. We're going to be enjoying. We're going to be fun. We're going to do so many teachings today as we have been doing. Now, as I always say to you, get your priority right. As a student, all you need to do is to focus on your what? Academics. You have the time now to do that is expected of you to do. A time will come, you may not even have that opportunity again. So please, I want to appeal to you, take your academic work very serious. So as tomorrow you can be able to pass this knowledge and you can be able to stand to give out the rightful attributes that you are meant to give out, either in science or art or any other area that you'll be focusing. Now let's take a look at a topic today, laws of indices. Laws of what? Indices. Now indices is a plural form of the word index. Index means power. And the plural form of indices is what? The plural form of index is what? Indices. Now they gave us laws in mathematics to treat this thing, indices. And mind you, for you to have the power, we'll be dealing with numbers that carries power on it. For example, I have something like this, x raised to the power of x raised to n. This x here is the base, and the power of this x is this n. X is the base, and the power of this x is n. And let's bring it now to what? I have something like this, 2 raised to the power of 2. This is not just 2. This is your ordinary 2. Your 2 is 2. And it also have an invisible 1 on top. Its power is just 1. And it will give you what? 2. But this means what? 2 times 2, which is what? 4. But mind you, this 2 is carrying a power. And that power is what? Is 2. And it means what? 2 times 2, which will give you what? 4. Are we there now? So now, but they gave us laws whereby we can what? Operate on this what? Power. Any number that have power. For example, we have 4. 4 raised to the power of 1 means 4. But whereby we are now having 4 raised to the power of 2. What does this mean? 4 times what? 4. Because this 4 is carrying a power, which is what? 2 on it. If you turn it to 3, it will become what? Times 3. If you turn it to 4, it will become what? Times 4. Are we there now? Now, laws of indices shows us how to treat these powers. And I'm going to pen it down 7 laws. I'm going to pen it down what? 7 laws. So let's go thereof. Let us go. Now, law 1, it states, that x raised to the power of m times x raised to the power of n is what? X m plus n. Are you seeing it? I'm just using this as a case study. X and n. Anytime you have a number that is this, you add it. So multiplication will give me what? Addition. Look at what it means. If we put an example like this, 2 raised to the power of 2 times 2 raised to the power of 2. I have 2 ways I can do this. I can say 2 times 2 will give me 4, times 2 times 2 will give me 4, which will be what? 16. Or you follow the laws, which say you pick one of the base, since it's the same, then you now say 2 plus 2, which will be what? 2 plus 2 is not 4? It's 4. And when you come up here, you have 2 times 2 times 2 times 2, which will give you what? 16. Okay? I come back again. Law 1. When you have the multiplication sign, it gives you what? Addition. You add the powers. Remember, the base must be the same. So when I have 2 raised to the power of 2 times 2 raised to the power of 2, if the base are the same. So I pick one of the base and I add the power thereof, which will give me what? 2 raised to the power of what? 4. So I have 2 times 2 times 2 times 2, which will give me what? 16. Okay? Now let's take law 2. Law 2. You have x raised to the power of n divided by x raised to the power of n, it will give you what? X m minus n. Are you seeing it now? We are looking at the laws of indices, how it goes thereby. So you are going to be having, I give another example. We have, let me say, 3 raised to the power of 4 divided by 3 raised to the power of 2. Now there are two ways I can do this. Are we there now? 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So if you have this, you can say 3 times 3 times 3. This is what it means. Why this one means 3 times 3. Let's just look at if this law is working. This is 4, sorry. 4. 3 times 3, 9. 9 times 3, 27. 27 times 3, you have what? 81. 3 times 3, is it not 9? So therefore, I have what? 81 divided by 9, I have 9. Are we there now? Or we go through the law. What did the law say to us? When you have this, you pick just one, you will now say 4 the powers minus 2, which will give me 3 raised to the power of what? 2, because 4 minus 2, is it not 2? And this thing means 3 times 3, which will give me what? 9. So what will that say to us? The laws are working. Follow the laws and it will be easier for you. Remember, we have taken the first law, we have taken the second law. Remaining how many laws? 5 laws. So let's look at the law 3. Law 3. They say to us, anything raised to the power of 0 is what? Is 1. So example, 100 raised to the power of 0 is 1. Anything raised to the power of 0 is 1. Mind you, every number is always raised to the power of 1. Or else, another number is added to it. For example, your 1, 2, 3, 4, 5, 6, 7, 8 to 9. This raised to the power of 1, this raised to the power of 1, raised to the power of 1. 2 raised to the power of 1 is 2. 3 raised to the power of 1 is 3. Are we there now? Or else, this now becomes 2. 2 raised to the power of 2 is what? 2 times 2, which is 4. 3 raised to the power of 2, which is what? 3 times 3, which is what? 9. But whenever any number is raised to the power of 0, it becomes what? 1. Take note. Law 3. Anything raised to the power of 0 is what? Is 1. Okay. Now, let's now look at the next law. Law 4. Law 4. Law 4. It states that x raised to negative n. If I want to remove this negative power, this negative sign in this power, what I'm going to do, I'm going to introduce 1 over x raised to the power of what? N. You introduce 1 and make this guy denominator, this number a denominator. You see the way I remove the negative sign? So an example like this, if I have something like this, 5 raised to the power of minus 2, how will I go about it? Permit me to clean this. 5 raised to the power of minus 2. To follow this law, it will not be 1 all over 5 raised to the power of 2, which will be 1 over 5 times 5, which is 1 all over what? 25. Are you seeing the law now? So to remove the negative sign, you introduce the power of what? 1. Make 1 the numerator and make that number the what? Denominator. Okay. Now, law 5. Law 5. We have x raised to the power of n bracket n. When this power is having external power, having another power outside. Remember, anything outside a bracket, if there is no addition sign or subtraction sign, it is a multiplication. So in the law, in that state, it will now be x raised to the power of mn. You see it now? X m raised to the power of n in bracket n. It is now giving me what? X raised to the power of what? M what? N. Are we there now? So if you have, example, you have 2 raised to the power of 3 brackets 2. This is power. What will you do? You say 2 raised to the power of what? 3 times 2, which will be what? 2 raised to the power of what? 6. Are we there now? And remember, this thing means 2 times 2 times 2 into what? 6 places. Remember the laws and follow the laws to solve thereof. Okay, let's quickly look at the other part. Quickly look at the other part. Law 6. Law 6 is stated that x raised to the power of 1 all over n. When you have a fraction as your power, what will it do? I will make the denominator the what? The root, and make the numerator the power. So it will not be root x mx in the bracket of what? 1. Are you seeing the laws? When you have a fraction as your what? As your power, you make the denominator your root, and you make the numerator your what? Your power. Example, you have 16 raised to the power of 1 all over 2. I'll follow this law. This law suits it. So it will now be root, square root of 16 bracket raised to the power of 1, which will give me what? 4 raised to the power of 1, which is the same thing as what? 4. Or I can take another example. 27 raised to the power of 1 all over 3. Are we there? This simply means the root. I see it now. This will not be cube root of what? 27 bracket what? 1. Which the cube root of 27 is what? Is 3. Because 3 times 3, 9. 9 times 3 is 27. Square root of 16 is what? 4. Why is it 4? 4 times 4 will give me what? 16. So therefore I'm having what? 3 raised to the power of 1, which is the same thing as what? 3. And the last law, which we are looking at, law 7. Law 7. It states x raised to the power of m all over, or will I say n all over n. The same now. In this you have 1 over 1m. This is a fraction and this is a fraction. But just that this is 1 as a numerator, but this is not going to have 1 as a numerator. The same law goes. You make the numerator your what? Your root. And the denominator your root, and the numerator your what? Your power. Example, I have 27 2 all over 3. It follows this law. So I can say the cube root of what? 27 with what? 2 as the power, following the law. So I'm going to be having 3 raised to the power of what? 2, which will give me 3 times 3. It will give me what? 9. Are we there now? Are we together? Or I can take another example to cap it up. We can say 16 raised to the power of 3 all over 2. What did this thing means? Square root of what? 16 in the power of 3. Remember, this is the sign of square root. Any other number that added becomes that root. This one is cube root. See it? Are we there now? So this will not be what? Square root of 16 is what? 4 raised to the power of 3. Which is what? 4 times 4 times 4. Which will give me what? 64. So these are the 7 laws of what? Indices. Indices is the plural form of a word. Index. Index means power. The plural form of index is what? Indices. And they gave us 7 laws. 7 laws. And we have just go through these 7 laws. We have many calculations in indices, but I will always not want to rush you, because my target is everyone in this classroom must catch every knowledge and details of it. Both in fraction, if I'm teaching pre-KG, if I'm teaching primary, we know how to go thereof. Are we there now? So mind you, I need your question. I need your question. And remember, my test time and my classwork I'll be giving to you. We'll just be going up, working with it. And what is my target? To bring you to an excellent in your what? Academic performance. Okay? At this point, we'll have to call the class, bring it to a close. And in our next section, we'll be looking at diverse areas of indices. We have looked at the 7 laws, we have looked at examples, we'll look at indices with equation, we'll look at indices with algebra in this power, we'll look at indices with using simultaneous equation to look at it. Then we'll switch over to logarithm. Every topic in mathematics will be treated. I just want you to ensure that you are following up with every pace that you need to follow up with. So I will need your question. Just chat it up, send your message, and let me see your question. From law 1, law 2, any point that is not clear can go by again so that we can catch it. And remember, Uncle love you, and Uncle want you to be best in your what? Academics. Goodbye.